Good day, Math Buddies! Sir Sherwin here, your math instructor. For today's video, we will be discussing about relations and functions. Of course, we will be guided with these objectives. First, define a function and demonstrate understanding of the definition, and determine whether a given set of ordered pairs is a function or a mere relation. To start with, let us ponder to this certain question. Are all functions a relation? Maybe, yes, no, not sure. Let's try to find out. How about this question? Are all relations a function? So to start with, let us define first relation. It is a set of ordered pairs of real numbers. It could be one-to-one correspondence, one-to-many correspondence, many-to-one correspondence, and many-to-many correspondence. Domain of a relation. It is the set of all first coordinates of the ordered pairs. Range of a relation. It is the set of all second coordinates of the ordered pairs. How about function? Function is considered to be the central idea in the study of mathematics. It is the set of ordered pairs x and y in which no two ordered pairs have the same first element. It is a relation in which it shows one-to-one correspondence or many-to-one correspondence. Take note of this one. Relations that are many-to-one are not functions. Example of a function. A motorcycle rider travels at a uniform speed of 80 kilometers per hour. How much distance can he cover in 7 hours? The problem shows the relation of time and distance. Relation can be shown using a table of values. This will be the solution. So we will have two rows. First, it is the time that represents per hour and a distance represented in terms of kilometer. In every hour, he reached 80 kilometers per hour. For the second hour, he reached a distance of 160. For the third hour, that would be 240 kilometers. For the fourth hour, he reached 320 kilometers. And for the fifth one, he reached 400 kilometers. 6 hours, that is 480 kilometers. And on 7 hours, he reached a distance of 560 kilometers. Thus, we can say 560 kilometers is the distance covered by the motorcycle rider in 7 hours. If we are to write the data in terms of ordered pairs x and y, this would be the sets of our ordered pairs. 1 and 80, 2 and 160, 3 and 240, 4 and 320, 5 and 400, 6 and 480, 7 and 560. If we are to determine the domain of the function, we have domain is consist of 1, 2, 3, 4, 5, 6, 7, while the range of the function consists of 80, 160, 240, 320, 400, 480, and 560. So let's try to give the domain and range of the following ordered pairs. Ordered pairs are 0, 1, 1, negative 2, 2, negative 5, 3, negative 8, 4, negative 11. The domain consists of 0, 1, 2, 3, 4, while range consists of 1, negative 2, negative 5, negative 8, negative 11. For the second set, we have the ordered pairs 5, 3, 10, 5, 15, 7, 20, 9, 25, 11. Domain consists of 5, 10, 15, 20, 25. And the range consists of 3, 5, 7, 9, and 11. Let us also state whether the given set of ordered pairs is a function or not. This would be the first set of ordered pairs. 1, 2, 2 and 2, 3 and negative 1. From this set, it is a function. Let's have the second set of ordered pairs. 3 and 0, 5 and negative 2, 5 and 0, 6 and negative 2. It is not a function because 5 is an element of our domain that is repeated. Let's try this one. Negative 1, 1, 0, 0, 1, 1, 2, 4. From this set of ordered pairs, we can consider that this is a function. This time, let's check this out. I'll be providing the names of the students that is considered elements of the domain and their corresponding heights as the elements of the range. So we have the student's name with their height. So Josheb, Shekinah, Francine, Glines, and Carmela. Josheb's height is 175 centimeters. Shekinah's height is 145 centimeters. Francine's height is 170. And Glines' height is 160. And Carmela's height is 168. This correspondence is considered as a function, since every element in the domain corresponds to a unique element in the range. Another one. The names of the students, again, being the elements of the domain, and their weights are the elements of the range. So, students' name with their corresponding weight, Josheb, Francine, Shekinah, Glines, and Carmela. Josheb's weight is 55 kilograms. Francine's weight is 45 kilograms. While Shekinah and Glines got the same weight, which is 38 kilograms. And Carmela has 48 kilograms. Again, in this example, this correspondence is a function because there is no repetition in the element of our domain. Let us have the third example. This time, the teaching subjects are the elements of the domain and the names of teachers are the elements of the range. So we have the subject and corresponding teacher's name. So we have the list of the subjects, namely mathematics, English, and Filipino. Under teacher's name, we have Ariel, who teaches mathematics, Mabel, who is also teaching mathematics, Melinda, who is teaching English, and Noemi, who is teaching Filipino. This correspondence is not a function since one element in the domain is paired with more than one element in a range. In this case, mathematics is paired to two teachers, namely Ariel and Mabel. Let us try. Let's tell whether the given rule describes a function or not. First one, the rule which assigns to each person his or her birth month. This is a function. The rule which assigns to each polygon its number of sides. This is a function. The rule which assigns to each student his or her teachers. This is not a function. Please try to think the reason why it is not a function. This time, let us discuss graph of a function. Graph of a function may be defined as the totality of all points plotted such that for every value of x and y in the function, there corresponds a point on the line. One way of verifying whether a given graph represents a function or a mere relation is through the vertical line test. The set of ordered pairs is a graph of the function of x if no vertical line intersects the graph of a function in more than one point. Let's have an example. This graph is an example of a function because through our vertical line test, it touches only at exactly one point. For our second graph, this is a function because our vertical line touches or intersects our graph at exactly one point. For the third one, this is not a function because in our vertical line test, vertical line intersects this figure at exactly 2 points. And for this one, this graph is considered not a function because the vertical line intersects this figure at exactly 2 points. Remember this, all functions are relations, but not all relations are functions. There you have it. Hope you learned something new today. God bless us all.